Hello YouTube, Sandra here, and welcome to the third lecture in our high school physics series. Today we're going to learn about average velocity. Study picture A above. 9 students are lined up with 3 meters apart from each other. They all start their watches at the same time, and then each stop their watch when their teacher, Andreas, passes them. They try this experiment twice, and the second time Andreas cycles a bit faster. Both times he tries to keep an even speed. Measuring results can be seen in the graph below. Distance s and time t are variable quantities. We can therefore describe the bike ride of Andreas graphically by putting the values into a diagram with t along the x-axis and s along the y-axis. What we get is an ST graph, such as in the graph previously. We can use that graph to figure out something about Andreas's average velocity, which is usually symbolized by a v with a dash over it. Average velocity is equal to distance divided by time, or dash v is equal to s divided by t. The standard international unit of velocity is meters per second. However, another common unit internationally is kilometers per hour. If we now try to calculate both velocities Andreas cycles with, we should try to read the graph as carefully as possible. Let us start with the slower ride. There it looks like Andreas got to about 28 meters in 7.9 seconds. So, dash v slow is equal to s divided by t, which is equal to 28 meters divided by 7.9 seconds, which is equal to 3.5 meters per second. The faster average velocity can be calculated the same way. In the diagram, we see that Andreas got 28 meters in about 6 seconds. So, dash v fast is equal to 28 meters divided by 6 seconds, which is equal to 4.7 meters per second. This is a simple example, since Andreas is moving roughly the same distance every second. Notice how you can easily compare velocities by looking at the graph. The faster Andreas cycles, the more the line leans. Or, to put it another way, the greater the slope. Let's take an illustrative example. Mark is late for the bus. He runs the first 200 meters in 30 seconds. Then he jogs the remaining 200 meters in 60 seconds. In total, he gets 400 meters in 90 seconds. So, average velocity is dash v equals s divided by t, which should give you 4.4 meters per second. We can illustrate this graphically. You see the red line in the graph. However, we could divide the velocities into 2 averages. If we take the first average, which is between 0 to 200 meters, as you can also see in the graph, we find that dash v1 is equal to s1 divided by t1, which should give you 6.7 meters per second. During the last 200 meters, the average velocity instead is dash v2 is equal to s2 divided by t2, which should give you 3.3 meters per second. Notice that the average of v1 and v2 is dash v1 plus dash v2 divided by 2, and it's equal to 5 meters per second. So not 4.4 meters per second. So keep this in mind when you try to solve tasks regarding velocity. Taking the average of 2 averages will usually not give you the same answer as simply taking an average of a whole journey. Now let's solve some tasks. Task 1a. Anna is cycling 900 meters in 2 minutes. Calculate the average velocity. I want you to try and solve this on your own. Pause the video if you don't want me to show you the answer yet. Alright, this one is really simple. You simply just find out how many seconds you have in 2 minutes. You should intuitively understand that it's 120 seconds. And then you simply take 900 meters divided by 120, which should give you 7.5 meters per second. B. Anna is cycling for 6 minutes with the average velocity 7.5 meters per second. How far did she get? Alright, so we know the average velocity, and we know the duration of time that she was cycling, 6 minutes. Try and solve this. Pause the video if you don't want to see my solution yet. Okay, so this is how you solve this. Find out how many seconds you have in 6 minutes. You have 60 seconds in a minute, so 6 times 60, that's 360 seconds. Now you know that distance divided by time is equal to average velocity. This means that if you take average velocity multiplied by time, you will get the distance, which is 2,700 meters, or 2.7 kilometers. C. How long is the time Anna needs to cycle 1,500 meters with average velocity 7.5 meters per second? Pause the video if you don't want to see my solution yet. In this problem, you know the distance and you know the average velocity, and you're trying to find out the time. Well, you simply take the distance and you divide it by the average velocity, which should get you 200 seconds, or 3 minutes and 20 seconds. 2. The graph shows the ST graph for a cyclist during 10 seconds. A. How large is the average velocity during these 10 seconds? Pause the video if you don't want to see my solution yet. So you know the distance and you know the time. How was it you got the average velocity again? Oh yeah, that's right. You divide the distance with the time, and you should get 1.8 meters per second. B. What is the greatest velocity the cyclist is riding with? Pause the video if you don't want to see my solution yet. Well, as you can tell, up until halfway, the line is actually a lot steeper, and then it gets less steep after 5 seconds. This means that she must have traveled with a higher velocity in the first 5 seconds. You take 12 meters divided by 5 seconds, and you get the average velocity of 2.4 meters per second. C. How far does the cyclist come in the last 5 seconds? Pause the video before I show you my solution. Well, you know that in the last 5 seconds, the line travels from 12 to 18 meters. Just look at the y-axis. You can graphically just determine immediately that it must be 6 meters. Thank you all for watching this lecture. Next time we're going to talk about constant velocity. Please consider donating to me on Patreon. It really does help me with making these videos. Take care, guys.